So I just wanted to show the effects of refraction. So here, as in the picture that I sent along with the email, it shows the different ways in which refraction happens, observed in daily life. And you can also ask them how that happens within the daily life that they see around them when they go home from school, when they're in the kitchen with their mom or their dad. And also perhaps if they have a pond nearby, then they can look at how that works. So, you know, you can use this as a kind of stimulus for what then could happen as they go out into their daily lives. Just as an experiment, I put the picture in the email as well. So it's about decoding the marbles disappearing act. So it's the idea of why do the water babies disappear? So it's about how light can be bent when it enters one medium for another, and how that is called refraction. But then they can actually do this experiment themselves. So if they don't want to, or you know, it's not possible to do it yourself, then you could actually just go through this experiment here, and they could try it at home perhaps. Maybe if they have also some of those bath, what are they called? Bath bubbles, bath pearls, that's it. Then they can maybe use that, some white bath pearls. It might be quite an exciting experiment to try, you know, maybe go and get some, or get the parents to get some. And yeah, so that's a way to do it. And there is a video that just shows it briefly here.
So, if you made a drawing of the water babies in this glass container, then what would the light rays look like? They go straight through. Do they?
Okay. So yeah, that's something that they can actually try, you know, in the class, or they can get prepared for being in the class, or they can try it at home if they want. But if not, then it's just a matter of observing it and how a similar situation could be created. So you could ask them, well, you know, how could we recreate this experiment perhaps, you know, or what's happening here. So just moving on. So this then goes on to like convex and concave lenses. So yeah, a lens is a curved piece of glass or plastic which bends light, and the lenses of spectacles, contact lenses, binoculars, magnifying glasses, microscopes, and telescopes make use of the refraction of light. When the light rays enter the lens, they are refracted towards the normal. And when the rays exit the lens, then they're refracted away from the normal. So there's a little bit of an explanation there, and then it asks the students to then go and try things themselves, like this, for example.
Does the water work as a convex lens? What's the evidence?
So at each point, then it's asking different questions. Now, if they're not familiar with the vocabulary like convex, then that's something that you can go back to the STEMworks channel for, and you can go into having a look at the different ways that the light goes off different lenses or reflects onto the mirror, or you can, you know, teach it with your own resources. So, you know, although this resource is really for a little bit of a higher level, what I quite like about this resource is that you can use it in combination with the STEMworks channel for creating the experiments if you haven't got enough, or if you need more support on that. So do have a look at this particular book, which is the Light Energy book within the NODMA, and please look at the one that is for Rebecca, Lucy, or Anna, and I sent the login details in the email, because in that way then you can apply or use these resources and adapt them in your own way. This one here, which is like the dispersion of light, of sunlight, I mentioned before in the other video that one of my favorite is crystals. So the way that I think, I used to do this with primary school children all the time, of using crystals, and just within a bedroom, in fact, or like, you can do it in the classroom, or they can do it at home. And, I love this one because it's almost like magic. It is magic in a way, but obviously it's science, but it looks impressive. And I think it keeps the students engaged because they see that it's, the color, that it appears to be white is actually made up of all these different colors of different wavelengths. And, you are able to see that when it passes through a prism. And so it takes you through the steps there. White light is made up of colors of different wavelengths. And then number 2, as the light enters the prism, colors of shorter wavelengths are refracted more than colors of longer wavelengths. And then it goes on to say, similarly, when light emerges from the prism, the colors are refracted from the normal at different angles. So again, it goes into the idea of refraction, whilst at the same time also talking about the different wavelengths of the color, of the light, sorry. And the dispersion of the white light produces a spectrum of 7 colors. So yeah, it goes into why they're colorful, why the white light is colorful, and why it disperses into those colors through those different wavelengths. So, it takes them through a series of steps. So although it might be a kind of complicated concept to grasp, I think it certainly does it in a way that takes them step by step by step. So that can be like another experiment that they can do within the classroom, or, that you can ask them, try it at home and see what happens. So yeah, I mean, this goes into a bit of an explainer, which I also like, and then it also links to things like, what are the other kinds of waves? So for example, like when we're listening to the radio, how do we get to know the radio? Because of radio waves. So it helps the children to think of the different kinds of curricula, the different kinds of subjects that, or concepts that they can be related to. So it's not just about light, it's also about sound, which you could also then say, how about the sound? Have you ever tried walking near water? And when you walk near water, and if you stand on the other side of of a lake or a pond, for example, then sound can travel quicker through water. Have you ever tried that? And that's one experiment that I used to try with my friends when we were at school, standing across from each other on a lake and seeing if we could actually hear our messages. I have to be a small lake, but it does actually work. So, there are different experiments that you can try that can be extended from this explainer, which is really interesting. So, what I wanted to show you is that this book is quite comprehensive in the sense of experiments, whereas, the STEM works is more about looking at those different areas and giving short interactive videos, whereas like the NODMA is really then, okay, let's try this experiment, and there's a whole range there. So yeah, this one here is when you look closely at the spectrum of dispersed white light, you can see a mix of many shades of the colors blurring the lines between 7 distinct colors. When white light falls on objects around us, they appear colored because they reflect some colors of light and absorb others. So it then just goes into a lot more detail about that. and it shows the combination of lights and colors. If you want to go a bit more kind of into that, you know, it explores it even further. So, you know, what I recommend is maybe if you have a look at this book before you take it into the class, and look at the different experiments that maybe, which are the best ones, which are the best ones that you want to use with the class, or maybe you want to use half the experiment, you know, because it goes into a lot more detail, or it goes into a higher level. So yeah, I mean, these are quite good because they're a little bit like apples in the sense that they have question and answer, but they're a bit more open in the sense of you do the experiment and then it asks the question, or you do the observation and then it asks the question. So there are a couple of questions there that you can go through. This one is, you know, what's the behavior of that light? And this one is more about looking at diagram and which of the following statements are correct. So it asks you to kind of, you know, compare and you know, based on the experiments that you've done. So yeah, just going into like a summary, you know, that's really what the summary of all the parts that, you know, have gone over about what is light. And that's something that, you know, you can do as a class. Perhaps before you want to go onto this page, you might want to ask, okay, can anybody summarize? Or maybe this can be like a way to, you know, start them off with their homework. You know, you might want to get them to do a concept map, which helps them to think about what is light, you know, where does it go? Like, so here's an example, and they could do their own concept map for, which is a really fun, you know, I used to love mind maps, and, you know, I get out my colors, you know, so you can get them to be really creative, and then they can come in the next day or the next lesson and with their own concept maps. They don't have to follow this one absolutely exactly. Obviously, the content would need to be correct, but the way in which they present that concept map could be completely different. And that's what I love about, you know, science, is that, you know, yes, you need to have the facts that are correct, but the way in which you present it, the way in which you experiment with that content is really up to the students. So, you know, this is a good homework activity if you want to get them to do this. Especially, I think this one is really good for those that perhaps are struggling with concepts, that really need to like see a visual idea of what those concepts could be and get an overview. Like maybe if, you know, for example, you have students that are really kind of focused on, okay, I really need to look at the details. I mean, that's one of my weaknesses, is that I used to be like drawing lots in science, you know, the tiny little details. And my science teacher would always say, okay, try and step back and look, what's the bigger picture? How does this fit in with everything else? So that's a really good, you know, you could assign this to different students depending on what their weaknesses and strengths are. If it's, you know, if there are people in the class that like prefer, you know, oh no, that's easy for me, I want to be tested, you know, you could ask them these questions, and they could, you know, test themselves for homework. You know, please feel free to actually give them the login details. It doesn't matter if, you know, they use Rebecca's and Lucy's or Anna's, you know, because that's fine. Or, you know, you can just copy the actual questions, you know, onto a document and use those as well. That's absolutely fine until we get you the book, of course, which I will try and get as soon as possible. You know, or you could actually ask them, like, you know, can you summarize the main points without looking? So that's maybe a good thing. Like, you could put it up and go over it in class, but then you can ask them, like, you know, without having this resource at home, you know, can you remember it? Or can you visually represent the main points, you know, however you would like to do it, whether that be through photographs, or you could make a film, that was one of my favorite, like making a little video about things that I had learned, you know, or they could tell a story about it. There's numerous ways. They don't have to do it like a list, which, you know, can be a bit boring sometimes. So, or they could even, you know, make models if they want, or they could tell someone about it. So like tell their parents about it and film that. You know, there's numerous ways that they can, you know, you can check their knowledge about whether they've learned the main points or not and how to present that. You know, alternatively, then you can use this resource and they can, you know, just test themselves by getting a sign in, you know, so we can just let me know if there is a specific way that, you know, we need to help you with that. Okay, so I'm going to stop there. So yeah, Light Energy is a really good book to use for experiments. I would recommend it. And again, you know, obviously to use it with the SEMWorks channel, and going back to apples, then you use apples for the actual, for the, not as a teaching tool on its own, because it's a little bit restricting if you just use it as a teaching tool, but really use that for diagnostic to see where they are, but then also for the evaluation at the end. You know, and please don't forget to use the mastery materials, because that really is going to help you to see where the students are, you know, and to really give an idea, okay, you know, 24% of them really do not know this specific concept. I need to cover that in class, or this is what they need to do for homework, or how can they pair up with their other students in order to teach them at home, or, you know, getting to pairs during class. And this is just really helpful. You know, and obviously this will give you the analytics will really give you an overview of where the students are struggling, where, you know, the students have not, you know, gone into it, and, you know, obviously where they've really mastered it, and where they don't, you know, need too much help, or you don't need to cover that particular material. So yeah, hope that helps. And yeah, again, let me know if there's any questions.